And now we are going to learn about the object-oriented programming using C++. We will understand the concepts like encapsulation, class, objects, inheritance, polymorphism, etc. And let's have our prompt here. We have our prompt. We are asking, let's have programs for core C++ concept or core object-oriented concept. First is class and objects, encapsulation, inheritance, then polymorphism. We all of these knowledge in this section to be clearly explained with code. And we are asking, let's have it in modular, usable, and extendability quality attributes in the code. Now, with that, we submit to generate the code for this concept. Now, let's let the Copilot work for us. So we just submit it, and it's working. Okay, it's generating. A lot of work to be done in this section. We have 4 key concepts of C++. Okay, so we have class bank account. So it's a good example of a real life example where you put deposit and money withdraw. All these are methods in the class bank account, owner's name, account number, get balance. All these are methods and display information, all the information in the class object. Savings account is derived from that account, and we have add interest, and then display info again, checking account, and derived from bank account, base class. And some methods here also withdraw from the savings. That's a different kind of withdrawal. And display info. Then abstract account. This is going to be used for virtual the polymorphism concept to apply bank basic account. Derived from that. Then here also we have withdraw, and there is a premium account. Derived from abstract class, abstract account. We have withdraw and deposit, all of them, add interest, and looks like it has done explaining how it's going. No, it's not done yet. Then demonstrating polymorphism using those classes, and here's main, all done in a minute. And all that we asked, so much code generated. It all depends upon how efficient is our query, our prompt. So that's how it will generate. And let's see what it did. We have, okay, class. It declared bank account as a class. Encapsulation is explained in the code. Inheritance is taken care. Like savings account and checking accounts are inherited from bank account. Bank account is a base class, and these two are derived classes. Polymorphism needs an abstract account class. Using that, it has virtual functions that enables runtime method selection. That's a polymorphism behavior. And we will look at the code and execute as we did before. Then we'll go through the execution output and try to learn what we have generated. Object-oriented programming using C++. Let's take this code to the editor We have the editor in the middle, and let's push that to the editor. And we have a new untitled editor. That's what we want, a new file. And our file name is, okay, what is the file name? Oh, object-oriented programming concept. Oops, I did not. Okay, I need to save that. We have untitled, keep it, and now save it. Okay, object-oriented programming, OOP, concepts.cpp. So we have that file, and here it is. And we open that. Let's hide the chat window again. We don't need it now. Hide it. And we expand this window to make it visible. We have the code, and we will execute that. We have the file here, object-oriented concepts, and compile C++, OP, output to OP, not CPP, without dot, and we have compiled successfully. There was no error. Now we execute that, OP, and then go through the program. And we have code from the top. Okay, we are using vector, string, IOStream, and IO manipulation, manip. Okay, we have bank class. This is the base class. Every bank account will have a owner's name, balance, and account number. So that's why it's a base class. It has a constructor, bank account, and those two, these can be initialized right here with the default values, but there is something called the parameter initialization list. So we can put it here like this. There are multiple ways we can assign values, default values now in C++, in modern C++. So this is one of the way. It's an old way, kind of. And then we have, this is a default constructor. And this one is parameterized constructor. So when we create the object, we will be passing account number as number, yes, and the name of the owner and the initial balance. And we have a deposit method where the amount you deposit and the balance will be incremented. And withdrawal balance will be decremented with the amount we withdraw if it is successful. And get account number, owner name, and balance. All these you can return and set those values. Owner name can be set, updated. Account number and balance are not used that way. It will be has to go through some other. Balance is always changed using a withdrawal or a deposit. So next we have display method, just displaying all these values. So that is the base class. Now the inheritance section is a savings account and derived from bank account. That's a base class, publicly derived. And we have this class, derived class has a constructor where the name, number, and the balance, and one more parameter, rate of that savings account. Savings account and checking accounts rate can be different. That's why. And that's not in the base class because they can change in the derived classes. Derived classes maintain that. And we have get interest rate, set interest rate that can change for the savings account. Adding interest and display information. Then checking account. Checking account has one more field called overdraft, and the savings account has interest rate. Those two are different thing. And overdraft limit for checking account. Checking account has no interest rate actually, so it will be kind of zero interest rate, I guess. And withdrawal method, same thing as earlier. You withdraw that amount and then take the base class deposit, the remaining, you update that. There's a logic here. We'll go through that when go to the output and abstract account. Now this we are heading to polymorphism area, section 3. So we have an abstract class which has also account, owner name, and balance. But one important thing is it has a virtual function with a pure virtual function. When you assign that virtual function to 0 like this, and withdrawal also pure virtual function, so it becomes an abstract class. We cannot create an object of an abstract class. So this should be derived to a derived class. Here it is, basic account, and which is deriving the base class, derived from. And this one should not have any any virtual function. Pure virtual function cannot be here, and they have to be redefined. Here, withdrawal, these two, withdrawal and deposit. Otherwise, if we don't have deposit, same signature, and the withdrawal, then this class also will become abstract class if we do not override that. That's called override. We have this is override. It's a keyword is that override. That means it is overriding a base class method. So this ensures that this is a method. This is overriding the base class method. Okay, and then premium account. That was a basic account. We have a premium account, and premium account has interest rate, monthly fees, and all that is there, additional fields. Then it also has withdrawal, and this class is also derived from abstract account class, a virtual abstract class. Then withdrawal and deposit have to be overridden in this class, and you define, you display the information. And we have calculate monthly fees, add interest. Those are additional function or method for this class. Now we have actual demonstration of the class object, demonstration of the app encapsulation, inheritance demonstration here, and polymorphism demonstration here. And all these methods are called in the main. So in the main, we have 4 functions demonstrating class objects, encapsulation, inheritance, polymorphism. We have executed that. Let's go through that quickly. We will not dive into every aspect of it. We can stop the video and see again. And let's see our class and object. And we have bank account number with this number, Alice Johnson, and 1,500 initial amount. And the object is created of the bank account. Bank account was derived from a bank account. Bank account was a base class. Yeah, that's the base class. And bank account, we have that here. Deposited. Okay. Encapsulation. No, that's not. That's encapsulation. We are looking at the class object here. This one. Okay. So we have this number, John Smith. John Smith with $1,000 with initial value, and then owner account, this is account two. Account one is an object without any values, and so that is, we are setting the values Jane Doe with 500, and the display information it shows 500 Jane Doe. And account two, and then we do some deposit and withdrawal, and then deposit 250 to what was 1000, so 1250 it will be, minus withdraw 100, so remaining will be 1150. John Smith, account two. And this one. Now account two, owner is this, balance is this much. And the key points of the class is class is defined as a blueprint of the object. Objects are instances of the class with their own data, and constructor initializes object when created, that we saw that. The constructor is with the same name as the class. That's the is a function method within the class, but is the same name as the class itself. We saw that, the account, bank account. And now we have demonstrating encapsulation. Encapsulation is encapsulating all the field. And bank account, we have bank account, encapsulation is a data member, balance account are private. Okay. And using getter and setter method, we have the set owner name. Now it is actually changing the owner name maybe, or not changing. Yeah, that's correct. So current owner is Alice Johnson, changed to Alice Smith. Last name is changed. Maybe that's why. And withdrawal is 2000. And because 2000 is insufficient, it had some data about how much? 1500. So it's denied. So that's what withdrawal method, it denies that. So insufficient fund. And that's what it is, the encapsulation. Your data member, and using setter and getter, you can set those values. The name was changed, but you do not use the name member itself directly. That's what they are private, and this method is public. Private cannot be used using dot notation of a class or using a pointer. They have to be gone through a, if they need to be changed, gone through a setter. If need to be read with a get method. And we have inheritance. Inheritance here, we saw that savings account and checking account were inherited from the basic account. Let's see. We have no bank account, simply bank account. So those two objects are created, savings and checking, different names and different number with different amount and so on. And savings has deposited 500, additional deposit, additional to that, and withdrawal from the checking is 200. After that, it will calculate the remaining and add interest in the savings, and checking withdrawal 1500, but it's still within the limit. So this is the checking account, and checking account 1500. It says within the limit, overdraw, but within the limit. Okay, checking account overrides overdraw. Oh, okay, checking account allows overdraft. Overdraw of allowed overdraft. There is an overdraft, and checking account has overdraft limit. Overdraft limit is set in the initial value. Overdraft limit, the limit, where is the limit? Limit default is 100, the last parameter. And this one. Okay, I'll move on and then create another bank account, the base class, base. And the base class object itself we can use and display information. So that is your base class here, base class display, and savings display here and checking display. Account, checking account, and the saving account. And then what does it say? Some key point. Derived classes inherits members of the base class, members from the base class, and derived classes can add new functionalities. Derived classes can override the base class method that we saw, override. And inheritance promotes code reusability and hierarchical relationship. So like a parent-child relationship. Now demonstrating polymorphism, another huge concept in C++ or object-oriented arena. And we have now we have three objects created: basic account, premium account, and basic account. So these two classes are derived from abstract accounts. So we have three abstract accounts pointers in an array, and they are being initialized with these two. One is basic account, another and another is premium account. And those values are displayed here: account ID, deposit. For using those pointers, we are calling the methods. So here the syntax is same. The base class, using the base class pointer, it is actually calling the method. For example, if index is 1, this premium account method display will be called, and deposit will be in that account. So every account here, three accounts, they are display and display deposit and display informations. We can see that account 1, it is David Brown here, David Brown. Account 2, Emily Wilson. The balances are all changed. These are different values are printed in those display information. And last account 3 is Frank Miller. Frank Miller here. And the key point the polymorphism is virtual functions enables runtime behavior. This is the runtime behavior. We don't know which function will be called in by seeing the code here, but only when we see which object it is pointing, that's the runtime behavior. And base class pointers can refer to derived class objects. So that's what we saw in this array. You can have individual pointers, or we are putting that in this array, and that is efficiently done. And override keyword ensures correct method overriding, so that ensures we saw that override method. Pure virtual function create abstract classes that define interfaces. Polymorphism allows processing object of different types uniformly. Polymorphism allows processing object of different types uniformly. This is what it is calling. So it is uniform, but different object it is operating on. And then we delete the account that because we have used new. That's another concept, the pointer concept, new and delete. And that's what it is, and end of the demonstration. And the delete, the destructors will be called in the delete, and those destructors are being printed. First, abstract class, basic account, abstract account, premium account, uh, and then basic account and abstract account. First the derived class, then the base class. First derived class and the base class. Base class is abstract account. So the destructors are called in the order of the derivation derived first in the constructor. The base class constructor will be called first. In the destructor, the derived class of constructor destructor will be called first. That's a different concept. We do have, we will see that later. New and delete. And that's about the object-oriented foundational concept, classes, objects, encapsulation, inheritance, and polymorphism. So we have that. With that, we covered the foundation concept of C++.